Alright, in this final video of Unit 6, we're going to talk about net ionic equations. So just a reminder that remember that when we're talking about double replacement reactions, many of these reactions are occurring in an aqueous solution. So in the last video, when I talked about predicting products, we looked at the dissociation of ionic compounds in water. So when something dissociates or dissolves in water, the cations and the anions separate, and it's actually a physical change. And so essentially what you have is a soup of ions in water. Now, that they are dissolved in water is what makes the reaction rate happen a lot greater. They can move around, they can come in contact with each other, but sometimes reactions happen and sometimes they don't. And we know that a reaction will happen if those ions recombine into a product that is insoluble and form a precipitate. Without an insoluble product, then all we do is we have a liquid of ions and we don't see any reaction happening. There's no indicator of a chemical change. So a net ionic equation actually represents the ions that are involved in the chemical reaction. So let's go ahead and look at an example. So if we were to put silver nitrate and sodium chloride together, so remember both of these are aqueous, so they're dissolved in water. They're actually both very clear liquids. You know what salt water looks like. It looks like clear liquid. We couldn't really tell the difference between it and water. And silver nitrate looks pretty much the same. So if we put these two together, they're going to swap partners, and the silver will go with the chloride, the sodium will go with the nitrate. And if I wanted to write out the full balanced equation, this is it, because they all have a +1 and a -1, so this is the full balanced equation. However, when we write a net ionic equation, this is just going to show the ions that are involved in the actual reaction. So we start by splitting the compounds into their ions. So we say silver, we write silver with a +1, nitrate with a 1-, sodium with a 1+, chloride with a 1-. So almost like they have been dissolved in water and separated into their ions like they actually do. Now if we were to write the products, if we used our solubility rules, we would see that sodium nitrate is actually the soluble product, so that still stays dissolved in the water, but what is the precipitate or the insoluble product is the silver chloride. So in this case, it doesn't dissociate into its ions, it stays together as a solid product. So we leave it together here, and then we show the ions for the sodium and the nitrate. So again, this indicates we're going to leave our precipitate together. Do not split them up into their ions because they are not ionized anymore. So then we'll take that and we'll simplify it by crossing out the ions that aren't directly involved. We call them the spectator ions. So they're basically floating in your soup of water and they don't really do anything. So what we are left then is that silver and chloride react to form silver chloride. So let's go back up, just look at this. So you see you've got nitrate and sodium on this side, and you've got nitrate and sodium on this side. So they actually cancel out, and they're not involved. Nothing really happens with them. What is actually reacting is that the silver is going with the chloride to form silver chloride. And that's why you end up with this as the net ionic equation. Alright, so I'm going to do some other examples here underneath the Elmo using the solubility rules, and then you'll have some to practice on a worksheet in class. So we've got barium chloride and silver nitrate. So let's go ahead and swap partners. So barium will go with the nitrate. Barium is a +2, nitrate is a -1, so Ba and then NO3, 2 plus. And then we have silver and chloride going together. So this would be AgCl. And we just did one with silver chloride, so we know that it's this, the insoluble precipitate, but let's just look at the rules just for some extra practice. So barium nitrate, it says all nitrates are soluble. So this is our aqueous or soluble product, and it says all chlorides are soluble except ones with silver. So this is my insoluble product or my precipitate. So this is going to be solid, and this is going to be aqueous, And we know that these two are aqueous because they are dissolved ions as reactant. So let's go ahead and then write our ions out. So if they're aqueous, we're going to write them and split them up into their ions. If it's the solid precipitate, remember we keep it together because it hasn't ionized. So we've got barium 2+, and we've got chloride, and there's two of them. So we actually put 2 chloride ions, which that's a 1-, plus silver, which is a 1+, and then we've got nitrate, which is a 1-. So I'll put ones here. Okay, so those are the ions that have dissociated in the water at the beginning. And then we're left with barium as an ion, so barium 2+. And then we have nitrate, and there's 2 of them, so we're going to put 2 NO3. It's a 1-. And then the silver chloride, remember we keep it together because it hasn't separated into ions, it's a solid product. So then we're going to go ahead and we're going to just cancel what we have on both sides, right? So we have barium over here and barium over here, it's going to cancel. We've got nitrate over here and nitrate over here, so it's going to cancel like this. And then we'll go ahead and make our list of what's actually involved, and then we'll balance. So we've got 2 chlorides plus a silver, and then we get silver chloride. And then if I want to go back and balance, I've got 2 over here, so I need 2 here, and 2 here, and then we can see that that reduces. So Cl minus plus Ag gives me AgCl. Okay, so that would be my net ionic equation for that reaction. Okay, let's do one more. So here, in this case, we've got sodium chloride and barium nitrate. So they're going to swap partners, and we're going to end up with BaCl2 and NaNO3. And then we need to identify which of these products is our precipitate. So let's go ahead and look at our solubility rules. And it says all chlorides except for silver, lead, and mercury, and all nitrates. So actually we have 2 soluble products. So in this case we would say that there is no reaction. Okay, let's go ahead and do one more where we actually have a reaction. Let me look one up here. Let's do silver nitrate and potassium phosphate. So this is one that we did in the last video where we predicted the products. So AgNO3 plus K3PO4, and that forms silver phosphate and potassium nitrate. And if we wanted to go ahead and balance that beforehand, we can put a 3 here and a 3 here. And if we look again at our solubility rules, we've got silver phosphate, and it says all phosphates are insoluble, so this one is going to be our solid precipitate, and all 3 other are aqueous. So we'll just separate into our ions. So we're going to have 3 silvers, and we'll have 3 nitrates, and we'll have 3 potassiums, and we have 1 phosphate. And then we've got our silver phosphate, so that is our precipitate, so we keep that one together. And then we've got 3 potassiums, and we've got 3 nitrates. Right? So then we just cancel what we got on both sides. So over here I've got 3 nitrates, over here I've got 3 nitrates. Over here I have 3 potassiums, over here I have 3 potassiums. So I'm left with my net ionic equation being 3 silver ions plus 1 phosphate ion will yield silver phosphate. Okay? This is my net ionic equation. So you'll have plenty of these to practice with. There's a classwork assignment on net ionic equations.